Azure Pipelines is a cloud service that supports continuous integration and continuous delivery, CI/CD, to build, test, and deploy your code to any platform. It integrates with various version control systems like GitHub, Azure Repos, and Bitbucket. Azure Pipelines provides two types of pipelines, Classic and YAML. Classic pipelines are defined using a graphical user interface, while YAML pipelines are defined using YAML syntax in a code file. Migrating from Classic to YAML pipelines can offer more flexibility, version control, and easier collaboration. Migrating to YAML pipelines offers several advantages. YAML pipelines are stored as code, making them easier to version control and review. They provide better support for complex workflows and conditional logic. YAML pipelines also enable you to use templates and reuse code, which can simplify pipeline management. Additionally, YAML pipelines are more portable and can be easily shared across different projects and teams. This migration can lead to more efficient and maintainable CI/CD processes. Classic pipelines and Azure Pipelines are created using a graphical user interface. They consist of a series of tasks and phases that define the build and release process. While Classic pipelines are user-friendly and easy to set up, they can become cumbersome to manage as the complexity of the pipeline increases. Changes to Classic pipelines are not versioned by default, making it difficult to track changes over time. This can lead to challenges in maintaining and troubleshooting the pipeline. YAML ain't markup language, is a human-readable data serialization standard that can be used to define configuration files. In the context of Azure Pipelines, YAML is used to define the pipeline as code. YAML syntax is indentation-based and uses key-value pairs to represent data. Understanding the basics of YAML syntax is crucial for creating and managing YAML pipelines. Key concepts include mappings, sequences, and scalars, which are used to represent different types of data structures. To set up a YAML pipeline in Azure Pipelines, you need to create a YAML file in your repository. This file defines the stages, jobs, and steps of your pipeline. Each stage represents a phase of the pipeline, such as build, test, or deploy. Jobs are collections of steps that run sequentially within a stage. Steps are individual tasks that perform specific actions, such as running a script or publishing artifacts. The YAML file is then committed to the repository, and Azure Pipelines automatically triggers the pipeline based on the defined configuration. Migrating build definitions from Classic to YAML involves translating the tasks and phases defined in the Classic pipeline into YAML syntax. Start by identifying the tasks in the Classic pipeline and mapping them to their YAML equivalents. For example, a task to build a .NET project in Classic can be translated to a .NET build step in YAML. Ensure that all necessary environment variables, triggers, and dependencies are correctly defined in the YAML file. Testing the YAML pipeline thoroughly is crucial to ensure it behaves as expected. Release definitions in Classic pipelines can also be migrated to YAML. In YAML pipelines, release processes are defined as stages within the pipeline. Each stage can have multiple jobs and steps, similar to build stages. Identify the release tasks in the Classic pipeline and map them to YAML steps. For example, a task to deploy to an Azure App Service can be translated to an Azure Web App deployment step in YAML. Ensure that all necessary approvals, gates, and conditions are correctly defined in the YAML file. One of the powerful features of YAML pipelines is the ability to use templates. Templates allow you to define reusable pieces of pipeline configuration that can be included in multiple pipelines. This can help reduce duplication and simplify pipeline management. For example, you can create a template for a common build process and include it in multiple pipelines. Templates can be stored in the same repository as the pipeline or in a separate repository. Using templates can make your YAML pipelines more modular and maintainable. YAML pipelines support conditional logic, which allows you to define conditions under which certain steps or jobs should run. This can be useful for creating more dynamic and flexible pipelines. For example, you can use conditions to run certain tests only on specific branches or to deploy to different environments based on the build status. Conditional logic is defined using the condition keyword in YAML. Understanding how to use conditions effectively can help you create more efficient and adaptable pipelines. One of the key benefits of YAML pipelines is that they are stored as code in your version control system. This allows you to leverage version control features such as branching, pull requests, and code reviews for your pipeline definitions. Teams can collaborate on pipeline changes using the same workflows they use for code changes. This can lead to better quality and consistency in your CI/CD processes. Additionally, having pipeline definitions in version control makes it easier to track changes and roll back to previous versions if needed. Testing and validating your YAML pipeline is crucial to ensure it works as expected. Azure Pipelines provides several tools and features to help with this. You can use the pipeline editor in the Azure DevOps portal to validate your YAML syntax and preview the pipeline. Additionally, you can use the pipeline linter to check for common issues and best practices. Running the pipeline in a test environment before deploying to production can help identify any issues and ensure a smooth migration. Thorough testing and validation are key to a successful migration. Once your YAML pipeline is up and running, monitoring and troubleshooting are important to ensure it continues to work as expected. Azure Pipelines provides several tools for monitoring pipeline runs, including logs, alerts, and dashboards. You can use these tools to track the status of your pipeline, identify any issues, and take corrective actions. Additionally, Azure Pipelines integrates with various monitoring and logging tools, such as Azure Monitor and Application Insights, to provide more comprehensive monitoring and troubleshooting capabilities. Following best practices can help you create more efficient and maintainable YAML pipelines. Some best practices include using templates to reduce duplication, leveraging conditional logic for flexibility, and storing pipeline definitions in version control. Additionally, it's important to keep your YAML files well organized and readable by using consistent indentation and comments. Regularly reviewing and updating your pipeline configuration can help ensure it continues to meet your needs. Following these best practices can lead to more successful and sustainable CI/CD processes. Migrating from classic to YAML pipelines in Azure Pipelines can offer several benefits, including better version control, flexibility, and collaboration. By understanding the differences between classic and YAML pipelines and following best practices, you can create more efficient and maintainable CI/CD processes. The next steps involve planning your migration, setting up your YAML pipelines, and thoroughly testing and validating them. With careful planning and execution, you can successfully migrate to YAML pipelines and take advantage of their many benefits.